cosmos is home to structures of such staggering scale that they contain thousands of complete galaxies. This journey invites you to investigate galactic clusters, the unseen giants that constitute the very framework of the universe. What mysteries do these immense gravitational titans conceal, and what can they teach us about the origin and destiny of everything we know? Prepare for an exploration of the universe's hidden architecture, where every galaxy is merely a tiny component of a much grander design. To begin, it's crucial to grasp what galactic clusters truly are. Picture a cosmic get-together where individual galaxies are the attendees. Some of these events are vast and crowded, with innumerable galaxies occupying the same cosmic region, while others are more intimate, hosting just a handful. In essence, a galactic cluster is a collection of galaxies gravitationally bound to one another, creating a single structure that can range from dozens to thousands of members, much like an exclusive society within the boundless expanse of space. The significance of these galactic clusters goes far beyond their sheer numbers. They are fundamental to comprehending the organization of matter throughout the universe. Much like how individual buildings group together to form a city, galaxies gather into clusters, which then assemble into even more massive formations. But what process is responsible for their creation? The story behind these cosmic megastructures is a dramatic saga of collisions and mergers that has unfolded over billions of years. Galactic clusters originate from small concentrations of matter that, as the cosmos expands, start to pull in more material through gravity. It's like a tiny speck of metal acting as a magnet, steadily attracting more filings and growing in size and strength. This accumulation consists of not just galaxies but also superheated gas and dark matter, an enigmatic substance that is pivotal to the stability and development of these clusters. Dark matter, which is thought to constitute about 85% of all mass in the universe, provides an invisible structural support system. It is the force that holds the galaxies together, guiding their movements and evolution. Without it, they would simply drift away into the void. Although we cannot see dark matter, its impact is absolutely essential to the cosmic web as we observe it today. As we delve into the world of galactic clusters, you should know that they are not all identical. There are rich clusters, which are densely populated with galaxies and contain vast quantities of matter, and poor clusters, which are more sparsely inhabited. You can imagine a large social event where some circles are far more crowded than others. This is precisely the kind of dynamic seen among these cosmic structures. This variation gives us a clearer understanding of the diverse conditions that can arise across the universe. Within a cluster, the constituent galaxies are anything but passive. They engage with each other in truly spectacular ways, with mergers and collisions being frequent events in these high-density environments. Think of two vehicles crashing at an intersection, but instead of stopping, they fuse into a single new entity. In a similar fashion, galaxies can merge, forging entirely new celestial structures and often igniting bursts of new star formation in the aftermath. The internal dynamics of these clusters present another captivating field of study. Galaxies are not static. They race at incredible speeds around the cluster's core, much like planets orbiting a star. This celestial ballet is directed by gravity, which serves as the conductor for each galaxy's orbital path. If you have ever wondered what governs the motion of these galaxies and what forces are at play, the answer is found in the complex relationship between gravity and dark matter, which together forge a truly mesmerizing environment. Galactic clusters also function as cosmic nurseries, where new stars and planetary systems are born. Similar to a factory manufacturing new products, these clusters offer the ideal conditions for stars to condense out of the surrounding clouds of gas and dust. This means that within these immense structures, the universe is perpetually being infused with new sources of light and energy. The evolution of our universe is inextricably linked to galactic clusters. As space continues to expand, these cosmic behemoths serve as the fundamental building blocks that define the universe's large-scale structure. By studying them, we can learn how the cosmos has transformed over eons and gain insights into what its future might hold. As we probe deeper into galactic clusters, many compelling questions emerge. How do we even see these giants from our vantage point on Earth? What kind of technology and which scientific methods are employed to analyze them? And looking beyond astrophysics, what are the broader implications of this research for our comprehension of the universe and our own place within it? The cosmos is an incredibly vast and enigmatic realm, and galactic clusters represent one of the primary keys to unlocking its deepest secrets. By understanding how they form, evolve, and interact, we not only broaden our cosmic awareness, but also take a significant step towards solving the profound mysteries that still pervade the darkness of space. These structures are truly a gateway to understanding the universe in its entirety. Galactic clusters are undeniably among the great wonders of the cosmos. But what defines them? Put simply, a galactic cluster is a massive assembly of galaxies bound together by their mutual gravitational pull. These are not just random groupings. Clusters can encompass anywhere from several dozen to many thousands of galaxies, making them some of the largest and most intricate objects in existence. Imagine a metropolis built in space, where each galaxy is like a skyscraper. Together, they form a breathtaking complex that pushes the limits of our cosmic perspective. What makes up a galactic cluster is equally fascinating. In addition to the galaxies themselves, these structures are saturated with incredibly hot gas, so hot that it often shines brightly in X-ray light, and an enormous quantity of dark matter. While we are unable to observe dark matter directly, its gravitational influence is indispensable for keeping the galaxies from flying apart. You can think of it as an invisible adhesive that preserves the integrity of this enormous cosmic structure. Without it, the galaxies would disperse as if nothing were holding them together. Some of these structures span for millions of light years, which means the distances between individual galaxies inside a cluster can be staggering. To help you visualize this, think of our own Milky Way as a single small tree in a forest, and a galactic cluster as that entire vast woodland, filled with diverse trees all interconnected within a complex ecosystem. The importance of these cosmic collections cannot be overstated, as their very existence offers us clues about how galaxies form and evolve over cosmic timescales. Studying galactic clusters allows astronomers to better grasp how galaxies gather and interact with one another throughout history. Much like observing different groups of animals in nature reveals their unique dynamics and relationships. The story of how these clusters come into being is a truly remarkable one. In the early universe, just after the Big Bang, matter was not distributed perfectly evenly. Over eons, these slight concentrations of matter started to pull in more material, giving rise to the first clusters as gravity acted like a cosmic magnet, drawing galaxies and gas toward a common center. A crucial element in the stability of galactic clusters is dark matter. Without its influence, we would be unable to explain why the galaxies remain bound together. You can think of it as the foundation of a house. Without that strong, unseen support, the entire structure would crumble and fly apart. By deepening our understanding of dark matter, scientists can unlock the secrets behind the formation and evolution of these massive cosmic systems, as it acts as an invisible skeleton, providing the necessary structure for galaxies to group together. You should also know that not all galactic clusters are identical. There are rich clusters, which contain a multitude of galaxies and a vast amount of material, and poor clusters, which are comparatively less dense and hold fewer galaxies. This classification system helps us appreciate the diversity of the universe and how galaxies organize themselves in various environments. Moreover, these clusters are sites of intense activity, as the galaxies within them constantly interact, collide, and occasionally merge, events that can spark the creation of new stars and add further complexity to life within the cluster. Have you ever considered the way galaxies navigate within a cluster? The dynamics of their movements are fascinating. Rather than traveling uniformly, they are engaged in a constant interplay, shaped by the gravitational pull of their neighbors. This gravitational dance can produce spectacular phenomena, such as the creation of giant elliptical galaxies through the merging of smaller spiral ones. Each cluster, therefore, serves as a kind of cosmic laboratory where large-scale experiments in galaxy and star formation are continually unfolding. As we continue our exploration of galactic clusters, it becomes increasingly clear that they are essential for piecing together the history of the universe. Each one functions as a sort of time capsule, holding clues about the events that shaped our cosmos. These structures tell a deep and rich story, charting everything from the formation of the very first galaxies to the evolution of the more complex structures we observe today, all governed by a delicate balance between cosmic expansion and the pull of gravity. In the end, galactic clusters are far more than simple groupings of galaxies. They are dynamic and mysterious environments ripe with opportunities for the birth of new stars, and they are fundamental to understanding the grand structure of the universe. By examining their composition, their formation process, and their internal dynamics, we gain invaluable insights into the deepest secrets of the cosmos, and by extension, the history of our own existence. Every galactic cluster tells its own distinct story, a cosmic narrative of development and transformation over eons. The impact of these massive structures, however, isn't confined to their own creation. Once formed, they exert a gravitational pull on their surroundings, attracting other clusters to forge even larger superclusters, which serves as a powerful demonstration that gravity's influence operates on scales far more immense than you might typically conceive. This grand interplay reveals a fundamental truth. Everything in the cosmos is interconnected, with clusters forming crucial nodes in a perpetually evolving cosmic web. Have you ever paused to think about how the very formation of these galactic clusters shapes the destiny of individual galaxies? As galaxies are drawn together, their interactions can ignite bursts of new star and solar system creation, seeding the universe with fresh elements and greater complexity. The life cycle of any single galaxy is deeply entwined with the life cycle of its parent cluster, illustrating a mutual dependence for their very existence. Ultimately, the assembly of galactic clusters stands as a profound testament to the formative power of gravity and the fundamental forces that sculpt our universe. Each one is a magnificent example of matter organizing itself from primordial chaos into intricate, stable structures. As we delve deeper into the cosmos, every new insight into galactic clusters brings us a step closer to comprehending our own place in the universe and the epic history we share with these formations. Human curiosity is the engine driving us to explore these cosmic behemoths, and each new investigation opens the door to more profound questions, compelling our continued search for answers. These clusters are not just astronomical curiosities. They are a reflection of our own journey for knowledge and understanding. So, what is the invisible force that holds galaxies together within the immense clusters we see scattered across the universe? The solution to this puzzle is found in the captivating and enigmatic concept of dark matter. To fully appreciate its significance, you can begin by picturing the universe as a vast, dark ocean. Within this cosmic sea, Galaxies are like luminous, beautiful islands. But the unseen current that binds them into groups is something we can neither see nor directly interact with. Dark matter. Dark matter is a form of matter that does not release or reflect any light or energy, which makes it entirely invisible and incredibly challenging to identify. So how can we be certain it exists? Scientists inferred its presence by meticulously studying the motion of galaxies inside these clusters. When we analyze how these galactic islands move, their behavior cannot be accounted for by the gravitational pull of visible matter alone. It is as if they are being influenced by a powerful, unseen medium. Imagine you are watching a game of soccer where all the players are running and kicking the ball, but some invisible influence is consistently keeping them grouped together on the field. This is analogous to what occurs in a galactic cluster. Dark matter functions like an invisible gravitational anchor, shaping how galaxies travel and arrange themselves. Without its presence, galaxies would simply disperse across space like dust in the wind, never forming the majestic clusters we observe today. One of the most compelling questions is about the origin of dark matter. Although we lack a conclusive answer, scientists have put forward various hypotheses. Some theories propose that it is composed of exotic particles that have so far eluded our detection, while other ideas speculate on a connection to dark energy, the mysterious force believed to be driving the accelerated expansion of the universe. This ongoing search to identify the true nature of dark matter feels like an exciting cosmic investigation, with every clue leading us closer to solving the universe's deepest secrets. Dark matter is not only essential for the initial formation of galactic clusters, but is also a key player in their ongoing evolution. As the universe continues to expand, this invisible substance provides a cosmic scaffolding that directs the growth of all large-scale structures. Without this unseen framework, galactic clusters would never have been able to accumulate the mass or achieve the shapes that we can observe in the present day, acting much like an unseen architect designing the universe's grandest constructions. It is also fascinating to see how dark matter mediates the interactions between individual galaxies within a cluster. When two galaxies draw near one another, their surrounding dark matter can act as a kind of gravitational buffer, softening the interaction and reshaping their paths. This process can result in galactic mergers, where two separate galaxies fuse into a single, larger entity, similar to two rivers flowing together to become one. These cosmic collisions are vital for the evolution of galaxies and the birth of new generations of stars. But what makes dark matter so incredibly difficult to detect? The challenge is rooted in its fundamental properties. Since it has no interaction with light or other forms of electromagnetic radiation, we are unable to observe it directly with our telescopes. This elusive quality is like trying to see the air around you. You know it's there because you feel its effects, but it remains invisible to your eyes. Scientists are therefore pursuing a variety of strategies, from deep underground experiments to remote astronomical surveys, in an attempt to finally pin down this cosmic enigma. Furthermore, dark matter is not distributed uniformly throughout space, but is instead arranged in a structure that resembles a vast cosmic web. It tends to gather in certain regions, creating what are known as dark matter halos that envelop galactic clusters. These halos are crucial for understanding how galaxies are drawn together and how they evolve over billions of years. You can think of it as a giant, invisible magnet, pulling galaxies into a cosmic dance that defines the very architecture of the universe, making these clusters perfect natural laboratories for our studies. Imagine galactic clusters as sprawling celestial metropolises, places where countless galaxies coexist, influence one another, and develop over cosmic timescales. However, you might be surprised to learn that these cosmic gatherings are not uniform. They come in various forms, each defined by its own distinct properties and attributes. Let's first explore what astronomers call rich clusters. Picture a vibrant, crowded city center, teeming with galaxies instead of people, often numbering over 100. In these dense, active environments, galaxies are constantly moving and engaging with each other, making them prime locations for scientific study. Conversely, we have poor clusters, which you can visualize as a quiet, sparsely populated village containing fewer than 30 galaxies. While they may lack the spectacle of their richer cousins, these less dense groupings are just as crucial, revealing that the cosmos is a place of both immense congregations and more isolated, tranquil regions. The distinctions between clusters extend beyond just the number of member galaxies to their actual makeup. Certain clusters are dominated by elliptical galaxies, which appear as smooth, rounded systems, much like ancient settled patriarchs. Others are populated mainly by vibrant spiral galaxies, younger and more energetic, with their elegant arms tracing complex patterns through space. The specific blend of these galactic types provides valuable insights into a cluster's past and the history of interactions among its inhabitants. It's crucial to understand that galactic clusters are more than just a collection of visible galaxies. They are also filled with immense quantities of dark matter. Think of it like the unseen gravitational field of a massive object, which you can't see, but whose effects are undeniable. This mysterious substance dictates the movement of galaxies and provides the fundamental structure for the entire cluster. Even though it remains invisible to our instruments, dark matter is the essential cosmic mortar that prevents these massive structures from flying apart. A fascinating aspect of these cosmic assemblies is that they are not static. They evolve. Throughout cosmic history, a poor cluster can gradually draw in more galaxies to become a rich one, a process you could compare to a small town growing into a bustling city over centuries. This galactic assimilation leads to mergers, ignites the birth of new stars, and introduces fresh dynamics, proving that clusters are in a perpetual state of transformation. The arrangement of galaxies inside a cluster is also a point of great interest. Some members might be tightly packed, while others remain more isolated, which leads to a wide range of gravitational engagements. These can vary from direct collisions and mergers to near misses, where galaxies gravitationally distort one another without combining. Such encounters are fundamental to galactic evolution, as they can set off waves of star formation and reshape the very architecture of the galaxies involved. We can also categorize galactic clusters based on their internal structure. Some exhibit a relatively even spread of galaxies, while others show a distinct hierarchy, with massive galaxies gravitationally commanding their smaller neighbors. The fundamental force responsible for their creation is gravity. Over eons, smaller galactic groups pull in more members, steadily growing into a larger assembly, much like a rolling snowball gathers more snow. Gravity serves as the relentless engine driving this cosmic consolidation, drawing ever more matter toward the cluster's core. When we probe these clusters, we find that some are incredibly ancient, having formed in the early epochs of the universe. These primordial structures serve as cosmic time capsules, offering us a window into the universe's distant past and showing how it is transformed. Incredibly, the dynamic environment within these clusters, with its frequent galactic interactions and bursts of star birth, could foster the development of planetary systems capable of supporting life. This means their significance might extend beyond cosmology and touch upon the very origins of existence. You should know that galactic clusters remain a vibrant field of astronomical investigation. Every new observation from our increasingly powerful telescopes deepens our knowledge of their formation and life cycles. Yet, As our comprehension grows, so do the profound questions we face. What if our current theories about dark matter are incomplete? Is it possible that other, completely unknown forms of matter or energy permeate the cosmos? Each discovery seems to open a door to even more complex puzzles, propelling us to push the boundaries of exploration.
Ultimately, dark matter is the fundamental scaffolding upon which our universe is built. Without its gravitational influence, the magnificent galactic clusters we observe simply could not have formed. It is the unseen force that holds galaxies in its grasp and directs their cosmic dance through time. So, the next occasion you have to look up at the star-filled sky, I encourage you to remember that what is visible is merely a fraction of reality. The great enigma of dark matter lies hidden in the darkness between those points of light. Each new finding advances our comprehension of the universe's enigmas and clarifies our own place within it. So, the next time you gaze up at the star-filled heavens, reflect on the fact that every single point of light might be a galaxy within a cluster, all contributing to a far grander cosmic saga. These universal giants truly form the underlying framework of cosmic architecture, weaving together galaxies, stars, and perhaps even life into a magnificent and sprawling celestial tapestry. The galaxies that populate a cluster are not just passive neighbors in space. They participate in dynamic and enthralling relationships. But how exactly do these immense cities of stars engage with one another? You can visualize it as a magnificent cosmic dance, where each galaxy is a partner in an intricate choreography. Some are drawn together, others drift apart, and a few merge in a spectacular fusion of light and matter. Galactic interactions can span a spectrum from gentle encounters to powerful collisions. As two galaxies draw near, their mutual gravitational forces begin to take hold, much like unseen magnets pulling them closer. This attraction can reshape their paths and sometimes causes their forms to entwine, producing an incredible visual spectacle. Can you picture two galaxies waltzing through space, their spiral arms interlocking in a cosmic embrace? One particularly compelling event is the galactic merger, which happens when two galaxies collide directly and fuse into a single, more massive entity. Throughout this process, not only do their stars intermingle, but their gas and dust clouds also combine, igniting the formation of new stars in a brilliant burst of creation. Have you ever considered what becomes of the stars caught in the crossfire of such a celestial impact? Some might be propelled into entirely new orbits, while others could be assimilated into the newly formed galaxy, like a cosmic game of billiards where a single collision can instantly alter a star's destiny. However, these interactions are not always so cataclysmic. In what are known as close encounters, some galaxies may simply pass near one another without colliding. During these flybys, gravitational influences can still prompt the development of new features, like extended spiral arms, or even the birth of a fresh generation of stars. Such events are like stimulating conversations between friends, capable of inspiring new ideas and profound changes. And what is the role of dark matter in these cosmic events? This mysterious substance, which we can't observe directly but know is present, profoundly influences the gravity of galaxies, and by extension, their interactions. It acts as an invisible scaffold that directs and orchestrates the movements of galaxies, much like a conductor leading a grand cosmic symphony. Without the presence of dark matter, the behavior of galaxies would be profoundly different. Interactions between galaxies also have a significant effect on the rate of star formation. When vast clouds of gas are compressed during a collision or a close pass, it can initiate the process of creating new stars, similar to how a dense atmospheric cloud can be squeezed to produce rain. Consequently, every galactic collision or encounter represents a potential opportunity for the birth of new suns that will illuminate the boundless universe. Another fascinating aspect of these interactions is how galactic clusters serve as nurseries for new galaxies. As galaxies merge and evolve within a cluster, they foster environments where new stars, and possibly new planetary systems, can emerge. In this sense, every cluster serves as a cradle for cosmic renewal, constantly reweaving the very fabric of the cosmos. When a cluster first assembles, its constituent galaxies start to interact and combine, which can ultimately lead to the formation of entirely new galaxies. You can think of it as a cosmic farm, where the crossbreeding of different species results in novel forms of life. Each new cluster that materializes presents an opportunity for a fresh galactic history to begin. Yet, not all of these interactions lead to creation. At times, galaxies can be torn apart or have their constituent parts stripped away during these encounters, a stark reminder that the universe is a realm of both creation and destruction, governed by a perpetual cycle of life and death. Can you imagine the destiny of a galaxy caught in the gravitational grip of a more massive one, only to be dismantled and transformed forever? The interplay between galaxies can also guide the evolution of individual members within a cluster. A galaxy might experience profound shifts in its structure and composition as a result of encounters with its neighbors. These transformations can be so dramatic that, over vast stretches of time, the galaxy may become unrecognizable. Have you ever paused to think about how many galaxies have had their shape and fate altered by a chance encounter, for better or worse? For astronomers, observing these galactic interactions offers a direct portal into the universe's distant past. By analyzing galaxies that have undergone mergers or close encounters, scientists can deduce what galaxies were like long ago and how they have evolved. It is akin to unearthing an ancient chronicle of cosmic history, where every page turned reveals a new chapter about the lives and relationships of galaxies. Today, astronomers employ powerful telescopes and sophisticated computer simulations to investigate these interactions in great detail. These technological tools enable us to view galaxies millions of light-years away, helping us better understand their behavior within the dynamic setting of a cluster. This pursuit is a thrilling voyage across time and space, where each new discovery brings us one step closer to comprehending the universe. Galactic interactions also invite us to contemplate our own position in the cosmos. We are all inhabitants of a universe that is in a constant state of flux, where every star and every galaxy is interconnected. Just as galaxies interact and evolve through their encounters, humanity can also learn, adapt, and progress through our own connections with one another. Isn't it astounding to realize that, within this immense expanse, we are all part of a single, magnificent cosmic story? Ultimately, the interactions among galaxies inside a galactic cluster represent a cosmic performance, filled with intricate beauty, complexity, and endless surprises. Every observation brings us closer to unraveling the profound mysteries of the universe and better understanding our own part in this grand design. From spectacular mergers to more subtle encounters, every galactic interaction has the power to shape the formation and evolution of galaxies. These events demonstrate that the universe exists in a state of perpetual change, reminding us that we, much like the galaxies, are on a continuous path of discovery, learning, and growth. The dynamics of galactic clusters present a mesmerizing cosmic ballet that tells us a great deal about the behavior of galaxies within these huge assemblies. Have you ever considered how galaxies navigate these enormous clusters? The reality is quite surprising, resembling a vast cosmic resort where each galaxy, like a person at the beach, moves in reaction to the powerful forces swirling around it.
Galactic clusters are astonishingly immense, often containing hundreds or even thousands of individual galaxies. You can picture a giant field of flowers, with each blossom representing a galaxy. Yet, these celestial flowers are not stationary. Some drift forward, others move backward, and a few appear to rotate. This motion is orchestrated by gravity, the fundamental force that binds the galaxies together, almost as if they were a group of friends holding hands while moving in unison. Gravity is the central actor in the dynamics of these clusters. When two galaxies draw near one another, they enter a gravitational contest that can ultimately result in their merger. Imagine two dancers approaching each other on a dance floor. At first, they keep their distance, but as their mutual attraction grows, they begin to spin and move together, creating an entirely new dynamic. This cosmic dance often leads to the birth of new stars from the material left behind by these galactic collisions. However, not all of these interactions are so graceful. On occasion, galaxies can undergo far more violent confrontations. These collisions have the potential to violently strip a galaxy of its gas and dust, which are the vital raw materials for creating new stars. In this way, galaxies can be compared to a group of children playing with a balloon. If it's squeezed too forcefully, it might just burst. So, while galaxies travel together, they also face the risk of losing their very essence. One of the most compelling aspects of galactic cluster dynamics is the wide range of speeds galaxies exhibit within these massive groups. Some galaxies race through space like marathon runners, while others meander more slowly, like people on a leisurely stroll. This variety in velocity is a direct result of the cluster's gravitational influence, which serves as the choreographer in this cosmic performance. Galaxies situated closer to the cluster's core typically move faster, as they experience a much stronger gravitational pull. Right at the heart of a cluster, galaxies can participate in an extraordinary event: the development of a supermassive black hole. This gigantic object can profoundly influence the motion of all nearby galaxies, much like a powerful magnet drawing in small metallic objects. This black hole not only affects the galaxies themselves, but can also redirect the flow of gas and dust throughout the cluster, triggering a domino effect that influences the entire surrounding region. As galaxies travel through space, they also generate shock waves in the intergalactic medium, creating a kind of cosmic sound that echoes throughout the entire cluster. These waves can heat the gas around them, which in turn impacts the formation of new stars. You could think of it like being at a concert, where the music suddenly intensifies, altering the atmosphere, and making everyone in the room feel a surge of energy. In a similar fashion, the movement of galaxies can energize the space between them. The structure and behavior of galactic clusters are both intricate and multifaceted. Astronomers have utilized computer simulations to model how galaxies act within these vast collections. These models function like a sophisticated video game, allowing researchers to watch how galaxies interact and gain a clearer understanding of the dynamic patterns that emerge. Still, simulations cannot account for everything. Mysteries remain, such as the true influence of dark matter, the invisible substance that affects galactic movement even though it cannot be observed directly. You can imagine being in a completely dark room and feeling the pressure of a gust of wind. You know something is present, but you cannot see it. In much the same way, astronomers are working to comprehend dark matter by studying its gravitational effects on the motions of galaxies. These galactic interactions can also produce unexpected outcomes, such as the phenomenon of cannibalistic galaxies observed in some clusters, where larger galaxies consume their smaller neighbors. This process can radically transform the cluster's overall structure, much like a few individuals at a party who draw all the attention, leaving others in the background.
Ultimately, galactic clusters serve as cosmic laboratories where we can investigate the forces that have sculpted the universe since its very beginning. The ways in which galaxies move and interact offer vital clues about the history and evolution of the cosmos. Every galaxy, every collision, and every merger represents another chapter in the magnificent story that is unfolding across the canvas of space. By studying these dynamics, we are not just witnessing a brilliant display of light and motion. We are also unlocking the secrets of how our universe was born and how it will continue to change long into the future. Within this immense ocean of stars and galaxies, every single movement tells a story, and each galactic cluster is another page in the great cosmic book of existence. The creation of new stars and star systems inside these clusters is a truly captivating process that illustrates how the universe is in a constant state of transformation. But what is actually occurring within these vast expanses populated by galaxies? Inside galactic clusters, gas and cosmic dust assume a critical role, serving as the essential building blocks for new stars. This gas, primarily composed of what is known as molecular hydrogen, is the substance from which stars are forged. However, this isn't merely a passive process of accumulation. Instead, a cosmic dance unfolds, one that is indispensable for the evolution of these nascent stars. As galaxies within a cluster approach one another, they generate gravitational forces capable of compressing this gas, initiating the star birthing cycle. Think of a group of friends gathering at a party. As they draw closer, the energy and excitement of their conversation build. In the universe, a similar concentration of energy transforms into heat and pressure, forcing gas to condense and ultimately collapse, giving birth to stars. But what happens when these stars emerge in such a densely packed environment? The competition becomes incredibly fierce, as stars within a galactic cluster do not grow in isolation, and the gravitational pull from other galaxies can redirect gas, sparking star formation in entirely new and unexpected places.
This process is like a cosmic relay race, where the baton is passed unexpectedly, revealing that star formation is far from linear, and is instead filled with surprising turns. As new stars are born, you might wonder about the fate of the old ones. More massive stars conclude their existence in breathtaking supernova, explosions that are not just a spectacle, but also generators of new materials. The heavy elements forged during these events are dispersed throughout the cluster, enriching the interstellar medium and supplying the necessary ingredients for the next generation of stars and planets, creating a continuous cycle where the death of one star fuels the birth of many others.
One of the most fascinating aspects is the role galactic clusters themselves play in this process. In the densest regions of a cluster, where matter is highly concentrated, star formation can be exceptionally vigorous as gas and dust accumulate, and the gravitational pull of nearby galaxies draws in even more material. This creates an ideal environment for birthing stars on a scale you might find hard to envision. Yet, this creative vortex isn't without its challenges. The intense radiation from newly formed stars can heat the surrounding gas, causing it to disperse before it can coalesce into more stars. A process not unlike loud students in a library disrupting everyone's ability to concentrate. This delicate equilibrium between creation and disruption is a central theme in modern astrophysics. You should also consider the phenomenon of star cluster formation, where groups of stars are born together from the same giant cloud of gas. Within a galactic cluster, immense pressure and gravity can cause these clouds to collapse collectively, creating entire families of stars that share a common origin. Much like a band where individual musicians unite to create a harmony greater than the sum of its parts. Furthermore, interactions between entire galaxies play a dramatic part. When two galaxies collide, their gases mix violently, setting off tremendous waves of star formation, and proving that cosmic collisions can lead not just to destruction, but to powerful new creation. By studying these galactic clusters, you get a window into both the past and the future of the cosmos. Astronomers analyze how stars form and evolve in these settings to uncover clues about how the universe's structure will develop over time. Every star that ignites is like a new page in the grand book of cosmic history, and by reading them, we can better comprehend our own position in this vast narrative. It's impossible not to see these cosmic giants as the stage for an incredible story of existence, where the cycle of stars being born, shining, and dying creates the potential for planets capable of supporting life, reminding us of the universe's profound complexity and beauty. In this cosmic theater, every galactic cluster is a stage where the greatest stories of creation unfold. You can think of them as enormous cities scattered across the universal landscape, playing an essential role in the cosmos's evolution. To grasp their influence, you must first accept that everything is interconnected. Each cluster is a fundamental building block in the grand cosmic structure, defining the very network you observe today. These clusters don't merely group galaxies. They function as cosmic incubators, attracting the gas and dust needed for new stars to flourish.
The influence of these massive structures, however, extends far beyond their own boundaries. It is well established that they shape the movement of nearby galaxies, altering their trajectories and determining how they assemble in space. This phenomenon is similar to how a large continent can redirect the flow of a river. In this way, galactic clusters serve as gravitational conductors, sculpting the destiny of all the galaxies in their vicinity. And what about dark matter? This enigmatic substance, which constitutes the majority of the universe's mass, is fundamentally important to galactic clusters. Without it, these giants simply could not form. Dark matter provides an invisible framework that holds galaxies together, steering their evolution and ensuring the cosmos remains connected and develops in harmony.
Dark matter provides an unseen framework that anchors galaxies and permits the assembly of galactic clusters. If this mysterious substance didn't exist, the cosmos would look profoundly different, filled with solitary galaxies instead of the magnificent congregations we can observe. As these clusters of galaxies develop over time, the galaxies within them also transform. The interactions between these galaxies can be incredibly powerful, resulting in spectacular mergers that forge entirely new cosmic structures. You can picture two galaxies like cars approaching each other on a highway. Their collision not only changes their paths, but also reshapes their forms and alters their makeup. Consequently, every galactic encounter holds the potential to spark the creation of new stars and systems, adding further complexity to the universal tapestry. Galactic clusters also stand as monuments to the universe's long history. By observing how they form and change, scientists are able to decode the mysteries of cosmic expansion. What can these colossal formations reveal to us about the distant past? Examining them gives us a clearer picture of what the cosmos was like in its infancy, and how it has evolved into the universe we recognize today. Each cluster serves as a kind of time capsule, preserving clues about the very events that shaped our cosmic environment. Another compelling area of study is the way galactic clusters engage with the intergalactic medium. The immense energy and dynamic forces within them can affect the gas and dust in the surrounding space, thereby promoting the creation of new galaxies. You can think of this process as being similar to how a plant can enrich the soil where it grows, creating fertile ground for the next generation. In this way,
Clusters are not just significant on their own, but also help cultivate the growth of new structures throughout the universe. The relationship between galactic clusters and the process of star formation is yet another captivating phenomenon. Clusters function like cosmic nurseries, where vast clouds of gas condense, eventually giving rise to new stars. The activity inside a cluster can be likened to a farm, where the ideal conditions allow new life to flourish. Without these uniquely favorable environments, a great many stars would never have had the opportunity to form. However, the ultimate destiny of galactic clusters is not predetermined. As the universe continues its expansion, these giants are also fated to change. Some are expected to merge with one another to form even more massive structures, while others may eventually disperse as dark matter pulls them in different directions. Within this cosmic ballet, every cluster fulfills its part in the ongoing evolution of the universe.
From a cosmological perspective, galactic clusters are indispensable for grasping how the cosmos has developed since its beginning. They assist us in tackling fundamental questions about the universe's nature, its rate of expansion, and its essential ingredients. What does all of this imply for your own existence? It serves as a reminder that you are part of something much larger, intrinsically linked to every star and galaxy across the immense expanse of space.
As we investigate galactic clusters more deeply, we find that they are not merely passive structures. They are dynamic, constantly in flux and teeming with activity. Every cluster has its own distinct story to tell, a narrative that informs us about both the past and the future of the cosmos. Through them, we can start to pull back the curtain on how the universe was born and where it is ultimately headed. The role of galactic clusters in the evolution of the universe is simply undeniable. They are not only the master builders of cosmic architecture, but also the guardians of time's deepest secrets. By studying them, you and I take another step toward comprehending our own position in this vast and amazing cosmos. So, the next time you gaze up at the night sky, recall that each point of light is a galaxy, and behind it may be a cluster, contributing its part to the grand symphony of the universe. Exploring galactic clusters does more than just deepen our cosmic knowledge. It connects us to the fundamental nature of existence itself. Isn't it extraordinary to contemplate everything contained within this immense network of galaxies and clusters? How is it even possible to see something so far away that its light has journeyed for millions of years just to reach us? This is among the most fascinating questions that arise when you discuss these galactic formations.
The answer lies in a blend of human ingenuity and highly advanced technology. By employing powerful telescopes and space-based satellites, we gain the ability to look backward through time and examine these giant clusters of galaxies. The methods of observation are quite diverse, with each one adding another piece to the universal puzzle. For instance, optical telescopes, which operate much like your own eyes, enable us to see the visible light coming from stars and galaxies.
However, the universe is not confined to just what your eyes are able to see. This is where other kinds of telescopes become essential. You can imagine the universe as an enormous dark ocean. While optical telescopes are like fishing boats skimming the surface, X-ray and radio telescopes are more like submarines, capable of diving into the depths to reveal hidden worlds. X-ray telescopes, for example, are indispensable for observing the superheated matter inside galactic clusters, which emits radiation at wavelengths invisible to the naked eye. Among the most fascinating formations found within galactic clusters are the massive shells of extremely hot gas. How can we possibly see them? This is precisely where X-ray technology proves its worth. When electrons within this superheated gas interact with radiation, they release X-rays that our specialized telescopes can detect.
This capability allows us to study not only the makeup of these clusters, but also their temperature and density. Alongside X-rays, radio telescopes have a critical role to play. These instruments can pick up radio waves emitted by certain galaxies and their interactions with one another. Have you ever considered how galaxies might communicate? Through these radio waves, we can acquire valuable information about the interactions and mergers happening deep within the cores of galactic clusters. We must also remember the significance of space telescopes, which, positioned above the Earth's atmosphere, can capture light spectra that are inaccessible to ground-based observatories. This approach yields much more exact and finely detailed information about the chemical makeup of galactic clusters. Using these powerful telescopes, we've successfully identified key elements like hydrogen and helium, along with other compounds that form the very fabric of these immense cosmic structures. The study of galactic clusters is also significantly advanced through international partnerships. Collaborative initiatives, such as the Hubble Space Telescope, which has been operational since 1990, have delivered breathtaking images that have completely reshaped our comprehension of the cosmos. As technology continues its rapid march forward, next-generation instruments like the James Webb Space Telescope place us on the very edge of uncovering new truths about the history and development of these galactic behemoths.
But what happens when direct observation isn't an option? In situations where scientists cannot witness certain cosmic events firsthand, computational modeling becomes indispensable. These sophisticated models enable astronomers to simulate the evolution of galactic clusters across vast stretches of time. You can think of it as creating a cosmic video game, where you can manipulate the interactions between galaxies and see how they respond under various conditions, helping us to better grasp their behavior and forecast their future.
Yet, light isn't the only carrier of information we get from the universe. The cosmic microwave background, often described as the lingering echo of the Big Bang, offers invaluable data regarding the distribution of matter throughout the cosmos. By studying how this relic radiation interacts with galactic clusters, researchers can deduce critical clues about the quantity of dark matter and its profound influence on the structure of the universe. As our technological capabilities grow, so does our capacity for observing these distant clusters. New telescopes are already being planned, each promising to unveil new perspectives on the universe. While only the future holds the answer to what discoveries lie ahead, one thing is clear. Every technological leap in observation moves us closer to resolving fundamental questions about the birth, life, and ultimate destiny of these cosmic giants. Exploring galactic clusters is a thrilling endeavor that marries human inquisitiveness with scientific rigor. Each photograph captured and every piece of data analyzed represents another stride toward a more profound understanding of the universe we inhabit. So, the next time you find yourself looking up at the stars, remember that every cluster you can imagine is a powerful symbol of our collective drive to venture into the unknown and solve the great mysteries of existence. Galaxy clusters are like sprawling metropolises scattered throughout the vast cosmic ocean. But what is their significance in our modern understanding of cosmology? This question compels us to examine the crucial part these massive structures play in the architecture of the cosmos and their link to the universe's expansion. Much like cities here on Earth, galactic clusters reveal how galaxies congregate and interact, offering vital insights into the history and fate of everything.
First, it's crucial for you to realize that galactic clusters represent the largest gravitationally bound structures in the universe. Picture a massive highway system connecting various cities. In this analogy, galactic clusters are the major intersections where countless galaxies converge. This intricate network, known as the cosmic web, shows us precisely how matter is arranged on the grandest scales, which is essential for understanding how the universe formed and expanded over billions of years.
The sheer variety among these clusters is equally captivating. You can find rich clusters, which are incredibly dense and packed with hundreds or even thousands of galaxies, as well as poor clusters that contain just a handful. This diversity not only informs us about the processes of galaxy formation, but also serves as a direct reflection of the universe's own developmental history. Every cluster acts like a historical document, chronicling a unique story of space and time. By observing these colossal structures, astronomers are able to chart the distribution of matter across the universe. The reason this is so critical is that dark matter, an invisible substance that emits no light, provides the essential gravitational pull that binds galaxies together within these clusters. Without a solid comprehension of dark matter and its effects, attempting to understand the cosmos would be like trying to solve a jigsaw puzzle with most of the pieces missing. When we consider the expansion of the universe, galactic clusters become indispensable tools for figuring out how the cosmos has behaved throughout its history. By analyzing their placement and movement, scientists can gauge whether the universe is continuing to expand, beginning to contract, or maintaining a state of balance. This information helps us address profound questions about the ultimate destiny of everything. Will it all fade into a cold, dark emptiness? Or will it eventually collapse in a cataclysmic event known as the Big Crunch? Additionally, galactic clusters function as natural laboratories for studying the effects of gravity and dark matter in extreme conditions. As galaxies within a cluster interact and merge, they unleash tremendous energy and ignite bursts of new star formation. This dynamic process is akin to a cosmic factory, where new celestial components are forged from recycled materials. It shows that clusters are not merely passive collections of galaxies, but active hubs of creation. Investigations into galactic clusters have also been instrumental in revealing the accelerating expansion of our universe. This led to the fascinating concept of dark energy, a mysterious force that seems to be pushing everything apart at an ever-increasing rate. Understanding how this pervasive energy interacts with visible matter is a central challenge in modern cosmology, and galactic clusters are one of our best means of studying it.
Furthermore, by examining galactic clusters, scientists can peer back in time to explore the conditions of the early universe. Observing clusters that formed billions of years ago provides a direct look at what the first galaxies were like and how they changed over cosmic eons. This unique window into the distant past allows us to piece together a more complete history of the cosmos from its infancy.
So, what possible link is there between these massive structures and the existence of life? By unraveling how galactic clusters formed and evolved, we can develop a clearer picture of how star systems are distributed across the universe, and by extension, the potential for life to arise within them. It raises the tantalizing question: could other clusters out there host worlds similar to our own? The study of these magnificent cosmic cities is far from over. Advanced technologies and powerful new telescopes are broadening our horizons for observing and analyzing these cosmic behemoths. Both space-based missions and ground-based observatories are currently dedicated to unraveling the enigmas of galactic clusters, striving to solve long-standing questions. In the field of modern cosmology, the significance of these structures is absolutely fundamental, as they provide critical insights into the universe's architecture, its evolutionary path, and its ultimate destiny. Every new finding concerning these massive assemblies moves us closer to comprehending the grand cosmic puzzle. When you consider galactic clusters, it becomes apparent they are far more than simple assortments of galaxies.
They serve as genuine charts of the cosmos, directing our quest for answers about our own position in the universe. Each breakthrough opens another chapter in the story of space, beckoning us to press on with our exploration and study of the immensity all around us.
Galactic clusters are not merely vast collections of galaxies. They also host some of the most captivating phenomena known to exist. If you've ever wondered what occurs when a galaxy confronts a supermassive black hole, the answer reveals a realm where gravity and energy merge in spectacular fashion. The majority of these clusters harbor a central supermassive black hole, with a mass that can be millions or even billions of times greater than our Sun. To visualize its effect, think of a massive vortex in a river. The black hole functions as the core of this cosmic whirlpool, dictating the motion of all the galaxies swirling around it.
Galaxies in these clusters don't simply circle the central black hole. They can be pulled inexorably towards it, setting the stage for cataclysmic encounters. On occasion, a galaxy that ventures too near is shredded by the overwhelming gravitational pull, creating a truly awesome cosmic display. When a galaxy is caught in this gravitational snare and starts to be devoured, it unleashes a tremendous burst of energy. This process can launch jets of particles and radiation at nearly the speed of light, producing luminous events visible across billions of light years. The impact of these black holes extends beyond just the energy they radiate. They also play a crucial role in regulating the birth of new stars inside the cluster's galaxies. An active supermassive black hole releases enough energy to heat the ambient gas and dust, which stops this material from cooling down and coalescing into new suns. This delicate equilibrium between generative and destructive forces is one of the most compelling features of galactic cluster dynamics. As scientists probe further into galactic clusters and their central behemoths, a fundamental question emerges. What is the origin of these colossal objects? The prevailing theory suggests they grow by merging with smaller black holes, which are themselves the remnants of collapsed giant stars. This entire sequence illustrates a constantly evolving cosmic ecosystem, where the interplay between galaxies and black holes gives rise to entirely new phenomena. A truly noteworthy characteristic of supermassive black holes is their capacity to shape the galaxies in their cluster through both gravitational force and energetic processes. This dynamic fosters an environment where vast reservoirs of hot gas become the nurseries for new galaxies. The relationship between black holes and galaxies can be seen as a kind of cosmic ballet, with each partner influencing the other in a timeless performance that has been underway since the dawn of the universe. Recent astronomical surveys have revealed that not every galactic cluster possesses a central supermassive black hole, and the reason for this discrepancy is still a mystery. This inconsistency introduces further questions regarding the evolution of the universe's large-scale structures. It's possible that the existence of a supermassive black hole serves as a clue, indicating the specific formation and evolutionary history of its host cluster.
In numerous instances, supermassive black holes appear to function as engines of galactic evolution. When galaxies merge or draw close to these giants, the cluster itself can become more varied and dynamic. Researchers have found that in certain clusters, like the well-known Virgo cluster, the central supermassive black hole has a direct impact on the pace of star creation within its constituent galaxies, highlighting the profound connection between these cosmic events.
Examining galactic clusters and their supermassive black holes inevitably leads us to contemplate the function of dark matter. While this substance is invisible to us, its existence is confirmed, serving as a hidden framework that provides the gravitational anchor for both galaxies and entire clusters. Enveloped by this dark matter, supermassive black holes are likely components of a far more intricate system that we are only beginning to comprehend. Moreover, probing these black holes and their activities inside galactic clusters carries profound implications for our comprehension of the cosmos as a whole. By analyzing how these giants engage with their environment, you can uncover clues about the universe's expansion and the development of its largest structures. The pursuit of these answers is a thrilling expedition, with every new finding unlocking fresh avenues of understanding. The function of supermassive black holes within galactic clusters remains a vibrant and active field of scientific inquiry. Ongoing technological progress in both telescopes and observatories is now enabling astronomers to witness these cosmic phenomena in greater detail than ever before. Each time we manage to photograph a supermassive black hole in action, we draw nearer to grasping the universe's immense complexity and our own position within it. The interplay between these cosmic behemoths and galactic clusters is not merely a source of scientific wonder. It also prompts us to contemplate our own existence. These giants serve as a powerful reminder of the universe's sheer scale and the fundamental forces that have sculpted the reality you and I experience. Every supermassive black hole stands as a monument to cosmic history, acting as a beacon that guides our search for answers about the universe.
Indeed, the supermassive black holes residing in galactic clusters are far more than just enigmatic phenomena. They represent the very keys to deciphering many of the cosmos's deepest secrets. As our exploration and study of them persist, every new finding about their properties and behavior refines our comprehension of the vast and intricate web that constitutes our universe. For decades, astronomers have been captivated by the puzzle of galactic clusters in the primordial universe. To picture what these colossal gatherings of galaxies looked like as the cosmos first began to coalesce, you must join me on a journey deep into the past, to an era when the universe was far younger and more turbulent.
Picture an immeasurable expanse of cosmic gas and dust, a boundless ocean where tiny pockets of matter started to gather together. These initial concentrations were the very seeds from which galaxies would eventually sprout. In its infancy, the universe was profoundly different from the one we see today. It was a high-energy environment where the first particles combined to forge the first atoms. Within this chaotic setting, galactic clusters began to emerge as dense zones where gravity's influence became paramount. As the universe continued its expansion, these dense patches exerted an ever-stronger gravitational pull, drawing in more and more surrounding material like immense cosmic magnets. Throughout this epoch, dark matter played an essential, though unseen, role in building the universe's framework. While we cannot directly observe it, its gravitational influence was, and still is, tremendous, providing the scaffold upon which galactic clusters were assembled from their earliest moments. With the passage of time, smaller collections of galaxies started to merge and expand, giving rise to much larger clusters. If you could have witnessed this from a distance, it might have looked like a cosmic chain reaction, similar to a line of falling dominoes. These galactic mergers did more than just increase the cluster's size. They fundamentally reshaped their internal dynamics and overall structure, creating the diverse formations we observe today.
One of the most remarkable features of these nascent galactic clusters was their sheer variety, as no two were exactly alike. Some were densely populated with countless galaxies, while others were far sparser, containing only a few members. You can think of this in terms of our world's cities. Some are sprawling, vibrant metropolises, while others are small, quiet towns. The population of galaxies and the frequency of their interactions within a cluster were decisive factors in charting its long-term evolutionary course.
Interactions among galaxies within these early clusters were incredibly fierce and energetic. Driven by the relentless force of gravity, galaxies didn't just draw closer. They frequently collided and fused in spectacular fashion. These dramatic cosmic events triggered massive waves of new star formation, and astronomers now understand that this dynamic and violent history is responsible for shaping many of the galactic clusters we see across the sky.
This brings us to the stars themselves. In the young universe, star formation was happening at an accelerated rate. The combination of galactic interactions and plentiful reserves of hot, dense gas provided the perfect conditions for creating new stars at a truly astonishing pace. You could say that every time two galaxies collided, it was like striking a match, igniting a fresh generation of stars that would go on to illuminate the cosmos.
Galactic clusters are vital not just for the galaxies they host, but also because they offer a unique window into the evolution of the entire universe. In their formative stages, these clusters functioned as cosmic laboratories, where the principles of gravity and large-scale structure formation were put to the test. By studying their ancient forms, we can better comprehend how the universe itself has transformed over billions of years.
It is crucial to recognize, however, that these early galactic clusters were anything but static. Much like a river that constantly changes its course, these clusters were in a state of perpetual evolution. The matter and energy contained within them were always in motion, ensuring their characteristics were never set in stone. In essence, each cluster behaved like a living, breathing entity, undergoing continuous transformation.
Modern telescopes now give scientists the ability to observe some of these galactic clusters as they existed in their infancy, allowing us to look back into their history through the ancient light that finally reaches us. Despite our advanced technology, however, countless questions still remain. The true nature of the early universe is still shrouded in mystery, and galactic clusters represent a major piece of that intricate puzzle.
The search for answers is ongoing, and each new insight brings us closer to a complete picture of how these massive assemblies of galaxies came to be. Each cluster preserves the story of its own birth and development, a narrative that reflects the evolution of the cosmos itself. So, the next time you look up at the night sky, remember that every point of light is part of a dynamic and fascinating history that links us directly to the origins of everything.
Ultimately, it's worth considering what all of this means for you and me. Gaining a deeper understanding of early galactic clusters doesn't just offer us a glimpse into cosmic history. It also helps us make sense of our own place in this vast expanse. With every glance toward the stars, you are effectively peering through time, into the very past that forged our present and may well determine the future of our universe.
Now, what if I were to tell you that the destiny of these galactic clusters is just as fascinating as their origin? For a moment, try to visualize that you are gazing out upon a cosmic sea of stars, where each cluster is a distinct island. The real question is, what eventually happens to these cosmic islands as time marches on? Will these galactic clusters stay fixed in their positions for eternity? Or are they destined to be transformed by cosmic forces that will ultimately remold the universal landscape? Composed of hundreds or even thousands of galaxies, these clusters are far from static. From the very beginning of their existence, they have been defined by perpetual motion and transformation, carried along by the expansion of the universe itself. Though that is only part of their story. Over immense spans of time, these colossal collections of galaxies are subject to interactions that redefine their destiny, much like pieces of a cosmic puzzle being constantly shifted. Just picture the magnificent chaos of such galactic collisions. The merger of two clusters is among the most spectacular events imaginable, a process where they meet like colliding oceans, generating vast waves of intermingling galaxies and igniting furious bursts of new star formation that reshape their very structures. So, what does this turmoil signify for their ultimate fate? While some galaxies will be integrated into a newly formed supercluster, others might be cast out and left to drift in isolation, like lone vessels lost on a cosmic ocean. Yet, the future of galactic clusters involves more than just mergers. Many will eventually lose their gravitational grip as their member galaxies slowly wander apart, causing the entire assembly to disperse its constituents across the immensity of space, much like old friends who eventually part ways.
Dark matter, which constitutes the vast majority of a cluster's mass, is the critical factor in these outcomes. Its immense gravitational pull is what binds the galaxies together, but shifts in its distribution can also trigger the very disintegration of these structures. If the balance of dark matter is disrupted or diminished, the cluster's integrity is compromised, as if the invisible tether holding everything together has finally snapped, leading to a permanent separation.
Looking even deeper into the future, across billions of years, the destiny of galactic clusters will become inextricably linked to the universe's relentless expansion. As space continues to stretch, clusters will drift further and further from one another, with some potentially being lost to the great intergalactic void. This process could transform them into solitary islands in a dark, empty sea, with their member galaxies receding from view at ever-accelerating speeds. With the passage of enough time, these clusters could become little more than ancient relics of a cosmos that was once vibrant and teeming with light. Certain scientific projections suggest that in the far future, all stellar activity within them might cease, leaving behind inert frameworks where the last stars have dimmed and an eternal silence descends. You can imagine a galactic cluster becoming a kind of cosmic fossil, a silent monument to everything that once was. Viewed this way, the existence of galactic clusters is a perpetual cycle of both creation and destruction. While their final destiny might appear desolate, every conclusion opens the door to new beginnings. Each interaction, merger, and eventual dissolution contributes to the formation of novel structures and the birth of new stars. It makes you wonder if the clusters we observe today could one day evolve into entirely new cradles for life. Ultimately, we are left to ask just how distant this future truly is. While the lifespan of a galactic cluster unfolds over eons, the cosmos operates on its own distinct rhythm, where what is brilliant and active today may be a mere echo of its former self tomorrow. This cosmic dance serves as a poignant reminder of the fragility and splendor of existence, even on such an enormous scale, showing us that every cluster has a unique story, filled with unforeseeable turns and wonders. In the vast expanse of the cosmos, certain galactic clusters shine as genuine marvels, so immense and brilliant that you can observe them from millions of light years away. It's worth exploring some of the most renowned of these structures, which have long captivated the minds of astronomers and space enthusiasts. These cosmic landmarks provide us with a deeper understanding of the universe's grand design.
Among the most celebrated is the Virgo cluster, a colossal assembly of over 1,000 galaxies, situated approximately 50 million light-years from our planet, making it a prominent feature of our own galactic vicinity. Picture a cosmic neighborhood where galaxies are so densely packed they seem to share a common celestial backyard, frequently interacting, and sometimes even merging. Its importance extends far beyond its sheer size, as its gravitational pull significantly influences the galaxies in our own local group, including the Milky Way, positioning it as a central figure in our corner of the universe.
Moving further out, we encounter the Coma cluster, another giant located about 380 million light-years from us. This cluster is famous for housing some of the most luminous galaxies ever discovered, including the notable galaxy NGC 4889. To observe the Coma cluster is to feel like an explorer navigating a sea of stars, dotted with brilliant galactic islands. The sheer density of galaxies in this region makes it an ideal laboratory for scientists studying how these immense structures form and evolve over time. Finally, the Perseus cluster deserves special mention as one of the most massive and radiant clusters known to exist. Its grandeur comes not only from its constituent galaxies, but also from the tremendous cloud of superheated gas that envelops it. This gas is so hot that it glows brightly in the form of X-rays, making the Perseus cluster a prime target for astronomers who use this radiation to unlock the secrets of cosmic dynamics and the distribution of matter in the universe.
When you observe a galactic cluster, glowing brilliantly in X-rays, you are essentially witnessing a cosmic lighthouse cutting through the deep black of space. Certain clusters of galaxies are truly one of a kind, like Abell 262, which is notable for its serpent-like elongated form. This particular cluster serves as a prime example of how interactions between galaxies can give rise to completely unexpected cosmic formations, reminding us that they are not static, but are constantly moving, grouping, and transforming in a celestial dance that has unfolded over billions of years.
A particularly interesting case can be seen in the Hydra cluster, which hosts a distinctive combination of both elliptical and spiral galaxies. This variety offers us vital clues into the history of how galaxies come into being. You can think of elliptical galaxies as wise elders that have ceased forming new stars, whereas the young and energetic spiral galaxies are bustling with cosmic activity. The interplay between these different galactic generations tells a compelling story of cosmic evolution. But what happens when entire galactic clusters are in the process of colliding? For a spectacular illustration, you can look to the El Gordo cluster. This object, situated over 7 billion light-years from us, stands as the most massive cluster discovered to date. A titanic collision between two separate galactic clusters is currently underway within it, unleashing a colossal explosion of energy and light. It's akin to watching two freight trains collide, a disaster that paradoxically leads to the creation of new stars and cosmic structures.
Observing these formations is not just about appreciating their beauty. It also deepens our comprehension of dark matter and the universe's energy. Each of these clusters functions as a natural cosmic laboratory, allowing scientists to investigate how matter aggregates and evolves through time. The specific distribution and movement of galaxies within them hold the secrets to the universe's long history.
Galactic clusters also assume a pivotal role in the birth of new stars. In regions where the concentration of gas and dust is exceptionally high, gravitational forces can trigger the compression of this material, leading to the formation of new stellar bodies. This process represents an unending cycle, where the demise of old galaxies paves the way for the emergence of new ones. In this respect, you can view clusters as celestial star factories, ceaselessly manufacturing new suns that will light up the cosmos for ages. The remarkable diversity found among galactic clusters also provides insight into the different environments where galaxies can thrive. Some clusters are heavily laden with dark matter, while others seem to have a much lower concentration. These variations can significantly shape the destiny of the galaxies residing within them, and understanding these differences is fundamental to solving the great puzzles of cosmology.
By studying galactic clusters, astronomers can also discern patterns that tell the story of the universe's past. Every cluster is like a history book, chronicling tales of collisions, mergers, and the pervasive influence of dark matter. It makes you wonder how many more stories remain undiscovered within these magnificent galactic assemblies.
Ultimately, galactic clusters are far more than simple collections of stars. They stand as monuments to cosmic history, giving you a glimpse into the past, present, and future of the universe. From the Virgo cluster all the way to El Gordo, each one has a unique narrative to share. So, the next time you gaze upon the night sky, take a moment to remember that out in the cosmic expanse, countless undiscovered galactic clusters are waiting, each with its own story to tell. Within the vast ocean of the cosmos, where galaxies are like islands in an endless void, a fascinating phenomenon is at play: cosmic radiation. But what is this radiation, precisely, and what effect does it have on galactic clusters? Imagine you are at the beach, feeling the sun's warmth on your skin. The energy you perceive is analogous to the radiation coming from stars and other celestial events. In space, however, this energy doesn't merely warm. It can fundamentally alter the formation and evolution of entire galaxies. When you consider galactic clusters, it is crucial to recognize they are not isolated entities. Instead, they are immersed in a sort of cosmic soup composed of various forms of radiation. This radiation, consisting of high-energy particles and photons, can influence the behavior of the galaxies within a cluster. You might think of it as a type of galactic climate, where conditions can shift dramatically, impacting the internal dynamics of these massive structures. So what kinds of radiation are we discussing? The cosmic microwave background, for instance, is like a faint echo from the Big Bang, a leftover from the energy that sparked our universe's existence. While this radiation is present everywhere, other types, such as those from supernova explosions and gamma-ray bursts, are far more intense and can radically change the environment of a galactic cluster. One of the most intriguing qualities of cosmic radiation is its capacity to ionize the gas found within clusters. When high-energy particles strike gas atoms, they can strip away electrons, which transforms the gas into a plasma state. This process is more than just a localized event. It carries significant implications for the formation of new stars. If the gas becomes ionized, it can lose its ability to cool and contract, thereby altering the entire process of star birth. Radiation can also directly influence the movement of galaxies inside a cluster. Picture each galaxy as a vessel on a turbulent sea. In this analogy, cosmic radiation acts like a powerful wind, pushing these ships in various directions, changing their courses, and sometimes even forcing them into collisions. These powerful interactions are often responsible for galactic mergers, a violent but creative process that can ultimately result in the formation of entirely new galaxies. Within these galactic clusters, radiation also holds a crucial role in how dark matter is distributed. This mysterious matter, which you cannot observe directly, interacts with radiation in highly complex ways. By analyzing how radiation affects the dark matter in a given cluster, astronomers can gather important clues about the structure and evolution of the universe as a whole. Imagine the cosmos as a grand puzzle, where every galaxy is a piece, and all these pieces are interconnected by the invisible threads of radiation. This cosmic energy can even aid in the creation of supermassive black holes, which lurk at the hearts of certain galactic clusters. These immense gravitational monsters pull in surrounding matter, and the radiation they unleash can have profoundly destructive effects on their cosmic neighborhoods. The interplay between this radiation and the material within a galactic cluster can give rise to powerful jets of particles, which blast outwards at nearly the speed of light and dramatically reshape the cluster's overall dynamics. But this raises a critical question about the effect of all this radiation on life. As these clusters are bathed in powerful energy, the very environments where life-sustaining star systems could form are significantly influenced. The precise conditions needed for a habitable world are incredibly delicate and can be easily disrupted by this constant bombardment of cosmic radiation. This intricate dance between energy, matter, and galaxies can determine whether a cosmic region becomes a cradle of life or remains a sterile stellar wasteland. Even with all our current knowledge, we are still faced with a vast number of unsolved mysteries, making the link between radiation and galactic clusters a vibrant and compelling area of active scientific research. Researchers are exploring profound questions, such as how radiation will behave within galactic clusters deep into the future, and whether it will contribute to building new cosmic structures as the universe's expansion continues. Investigating these phenomena not only deepens our comprehension of the present, but also offers a glimpse into the ultimate fate of our universe. It is crucial to recognize that cosmic radiation is merely one component in the incredibly complex web of interactions that define galactic clusters. Every new discovery we make only opens the door to more questions, and each of those questions brings us a step closer to truly understanding our own place in the cosmos. So, the next time you gaze up at the night sky, I want you to remember that you are witnessing a universe teeming with dynamic forces, where cosmic radiation is a key author in the story of galaxies, and perhaps of life itself. Have you ever found yourself staring at the stars, wondering if we are truly alone, or if life exists out in those far-flung systems? The solution to that ancient question might be more attainable than you realize, with a significant clue hidden within the study of galactic clusters. These colossal assemblies of galaxies are much more than just beautiful objects. They may hold the key to understanding the prevalence of life in the universe. Think of galactic clusters as immense cosmic cities. In this analogy, each galaxy is a towering skyscraper, and the gravitational interactions between them are like the complex social dynamics of a bustling metropolis. The way these galaxies engage with one another can directly determine the rate of new star formation, a process absolutely essential for the emergence of planetary systems and, eventually, life. In the dense environments of galactic clusters, vast clouds of gas and dust are drawn together, collapsing under their own gravity to give birth to new stars. When multiple galaxies draw near one another, this process can be dramatically accelerated. The gravitational encounter can cause cosmic gas to cool and condense far more rapidly, triggering a burst of star creation and turning the entire galactic cluster into a stellar incubator. Of course, we must also consider dark matter, the mysterious substance that, while invisible to us, provides the fundamental scaffolding for the universe. You can visualize dark matter as an unseen cosmic web that underpins all large-scale structures, including galactic clusters. Without its immense gravitational influence, galaxies would simply lack the pull to remain bound together in these massive congregations, which in turn would impact the conditions for life. Because galactic clusters are such prolific star-forming regions, they also become factories for the elements crucial for life, like carbon and oxygen. As massive stars reach the end of their lives and explode, they disperse these vital elements into space. This enriches the interstellar medium, providing the raw building blocks needed for the formation of new planets and, potentially, the origin of life itself. Galactic collisions within a cluster can be incredibly dynamic events. When two galaxies merge, they don't just combine their mass.
the impact also ignites a massive wave of new star formation in what can be seen as a spectacular galactic rebirth. This suggests that life might emerge from these grand cycles of cosmic creation and destruction, with the interactions inside galactic clusters playing a central role in the process. Some compelling theories even propose that galactic clusters could serve as a cosmic transit system for life. Material blasted from galaxies during supernova explosions might travel across the intergalactic medium, eventually arriving in other star systems. This raises a fascinating possibility. Could clusters be responsible for seeding life throughout different corners of the cosmos? The close proximity of galaxies within a cluster also promotes the transfer of matter and energy between them. In such a vibrant environment, unique conditions could develop that are favorable to life. For instance, the energy generated by these galactic interactions might create warmer zones, making certain planets more temperate and possibly more habitable than they would be otherwise.
However, the picture is not entirely rosy, as the conditions within some galactic clusters can be intensely hostile. Extreme gravitational forces and lethal doses of cosmic radiation can render many regions completely inhospitable for life. This stark contrast between nurturing and destructive forces compels us to question whether life in the universe is a common occurrence or an extraordinary rarity.
The search for extraterrestrial life has traditionally centered on planets around stars much like our own sun. Yet it's thrilling to entertain the idea that life might arise under entirely different circumstances, such as within systems forged from the unique stellar nurseries of galactic clusters. This perspective broadens the horizon of possibilities for how and where life might flourish throughout the cosmos, prompting scientists to continue their exploration of this deep connection. Every new finding moves us closer to grasping not only how the universe's structures take shape, but also how they might impact the potential for life beyond our world. This fascination with cosmic life compels you to consider your own place in it all. If clusters of galaxies function as nurseries for stars, and by extension planetary systems, what other marvels does the immense cosmos have in store for us? The pursuit of these answers is the very engine that propels science forward, with each discovery representing a potential piece in the grand puzzle of universal life. It has become apparent that galactic clusters are far more than simple collections of galaxies. They represent hubs of cosmic activity that may hold the key to some of humanity's most profound questions. Is there anyone else out there? How did life begin on our planet? And could it have emerged in other places? These inquiries resonate through every part of the cosmos, and galactic clusters might just be the means by which we unlock their secrets. So, what is the relationship between galactic clusters and string theory? This question might feel abstract, as if we are discussing two entirely separate realms of reality. Yet, within the intricate web of the universe, everything is connected. String theory stands as one of the most compelling and intricate frameworks physicists have devised to decipher the universe's fundamental nature. But how can a concept as abstract as string theory be tied to the colossal galaxy clusters that define our cosmic landscape? To start, let's consider the universe's basic architecture. Galactic clusters are akin to immense islands floating in a dark cosmic ocean, with these islands comprising galaxies held together by the force of gravity. But what about the underlying fabric that binds all of this? This is where string theory enters the picture. The theory posits that what you know as subatomic particles are not merely infinitesimal points, but are instead tiny, vibrating strings of energy. Just as a violin's strings create different musical notes based on their vibration, these fundamental strings can generate the various particles and forces that construct our universe. How does this connect back to galactic clusters? Imagine that every string within this theory has the power to influence the matter and energy surrounding it. The interplay of these strings at a foundational level could very well dictate how galaxies congregate and behave within a cluster, suggesting that the cosmos is governed by the same essential laws from its largest structures to its smallest components. It is truly remarkable to think that when scientists analyze the dynamics of galactic clusters, they could simultaneously be uncovering the secrets of string theory. What if the very patterns of how galaxies move and group together offer clues about the nature of these elemental strings? The vibrations of strings could shape the distribution of dark matter, the enigmatic substance that is critical to the formation of galactic clusters. This invisible material, whose presence we can infer but not directly see, might be a direct manifestation of the properties of strings. Consider dark matter as an unseen adhesive that binds galaxies together inside a cluster. If the characteristics of dark matter are influenced by strings, then examining these clusters could provide new pathways to understanding the mechanics of how these gigantic galactic groupings assemble. A captivating element of string theory is its proposition that space and time are not static concepts. Instead, they are pliable entities molded by the interactions of strings. This leads to a fascinating inquiry. Could the behavior of galactic clusters also be a reflection of this cosmic flexibility? If space itself is malleable, then perhaps galactic clusters are not just moving through it, but are actively shaping it, thereby leaving an imprint on the large-scale structure of the universe. With every new breakthrough in astronomy and physics, even more questions emerge. Could it be that galactic clusters are essentially natural laboratories for putting string theory to the test? Astronomers are relentlessly scanning for patterns in the distribution of these clusters that might yield data on the very structure of space-time itself. The link between what you observe in the night sky and what occurs at the deepest levels of matter is a puzzle that continues to defy our comprehension. Moreover, the study of galactic clusters might provide insights into the nature of gravity, which is a cornerstone of string theory. By understanding how galaxies aggregate and interact within a cluster, we might begin to unravel the mysteries of quantum gravity, a domain where string theory aims to unite gravity with the other fundamental forces of nature. Some scientists even venture to suggest that by delving into galactic clusters, you can not only better understand our cosmic origins, but also catch a glimpse of the universe's destiny. If string theory proves to accurately describe reality, we could be on the verge of a revolution in our comprehension of everything, from dark matter to the formation of galactic clusters. The quest for knowledge at the crossroads of cosmology and string theory is a thrilling expedition. Each new piece of information about galactic clusters could be another clue that draws us nearer to understanding not just how our universe was born, but how it operates at its most fundamental level. In this cosmic ballet, galactic clusters and strings become entwined within a tapestry of mystery, where every thread contributes to the story of the cosmos. As you continue on this journey for knowledge, it's crucial to remember that each answer gives rise to new questions. String theory is still a discipline shrouded in enigmas, but every discovery made about galactic clusters could be a step toward untangling the complexity of reality. Investigating the bond between these cosmic titans and fundamental strings is more than a scientific objective. It's an adventure that connects you to the universe in its entirety. It serves as a powerful reminder of how little we truly know, and just how magnificent the reality that surrounds us is. Galactic clusters are genuine titans of the cosmos. Yet, for all their magnificence, many of their characteristics are still veiled in secrecy. A primary puzzle concerns dark matter, which is believed to constitute over 90% of the matter in the universe, though its fundamental nature is still a complete enigma.
Researchers are actively working to understand how this unseen substance governs the formation and behavior of galactic clusters, which perhaps couldn't have formed in the first place without it.
We are also captivated by the function of supermassive black holes residing at the core of certain galactic clusters. It seems paradoxical that these cosmic behemoths, which consume all surrounding matter, could also steer the development of their entire cluster. Current theories even suggest a connection between these black holes and the birth of new stars, raising the possibility that they are not only forces of destruction, but also instruments of cosmic creation.
The way galactic clusters have evolved throughout cosmic history is another subject of intense fascination. Astronomers have seen evidence that many of these structures pass through periods of heightened activity, when gravitational encounters between galaxies ignited waves of star formation. This leads us to question their future, with the potential for them to merge with other clusters being one of the most debated possibilities.
This brings up an interesting point about star birth. What is the specific function of galactic clusters in this process? While the high density of matter within them is known to spur star creation, the factors deciding whether a star forms inside a cluster or in the vast emptiness of space remain unclear. Thinking of clusters as immense stellar nurseries also invites us to wonder about life itself. Could some of these environments provide the ideal conditions for life-sustaining planetary systems to emerge, making us reflect on our own cosmic origins?
An often underestimated factor is the effect of cosmic radiation, which originates from cataclysmic events like supernovae and black hole activity. This intense energy can reshape the dynamics of a cluster, impacting both star formation and the development of its constituent galaxies. As our exploration deepens, we encounter theoretical frameworks like string theory, which hints that the cosmos might be vastly more intricate than we currently grasp and could hold keys to understanding cluster structure and the true nature of gravity.
Even with all our progress, a great number of questions remain, compelling us to push our investigations further. For instance, what exactly occurs when these massive clusters collide, and how do they restructure themselves in the aftermath? Such events can initiate intricate processes that give rise to entirely new cosmic formations. Our search also points to other phenomena, such as the proposed filaments of dark matter, that might link clusters together, creating a vast invisible network that could redefine our understanding of the universe's large-scale structure.
Looking ahead, the examination of galactic clusters offers a remarkable chance to deepen our comprehension of the universe. With technology advancing at a swift pace, our capacity to observe and analyze these enormous assemblies is constantly improving. This ongoing quest, fueled by human curiosity, brings us progressively closer to solving long-standing cosmic riddles. You can think of each cluster as a sprawling galactic city, where every star and galaxy contributes to a grander story that, in turn, helps us understand our own place in the cosmos.
You should know that galactic clusters are far more than mere collections of galaxies. They are vibrant, evolving communities where members interact and merge. Have you ever stopped to consider how these interactions might sculpt the destiny of individual galaxies and perhaps even the universe itself? The key lies in gravity and dark matter, which together form an unseen framework holding these structures intact. This process is like a grand cosmic dance, where galaxies swirl, collide, and combine, reminding us that the universe is in a constant state of dynamic transformation.
A crucial outcome of all this activity is the creation of new star systems right within these clusters. As galaxies draw near one another, their immense clouds of gas and dust are compressed, often igniting a spectacular burst of stellar formation.
It is on this immense celestial stage that the constant cycle of cosmic change and rebirth truly unfolds. A thrilling spectacle of creation happening on the grandest scale imaginable.
You can think of each cluster as a stellar factory, where the precise conditions allow for the birth of new lights in the sky. These galactic assemblies also have a vital role in the universe's development, as their distribution and clustering help astronomers solve the puzzles of dark energy and the cosmos's accelerated expansion. Essentially, every cluster is a building block in the grand cosmic architecture, and studying them helps us grasp the very shape and future of our universe.
So, when you look up and observe these distant formations, you are literally peering into the past, directly into the history of the universe itself. Every cluster acts as a chronicle of events that have transpired over billions of years, holding clues that bring us closer to understanding how the cosmos began and what its final fate might be. Perhaps you're now wondering what else is left to uncover in this field. Despite all we've learned, many questions remain unanswered, such as the intricate link between dark matter and the formation of these clusters, or how cosmic radiation interacts with them. The research pushes forward, and every new finding deepens our insight into the universe's greatest mysteries.
The importance of these galactic groupings also extends beyond the realm of astronomy, touching upon the possibility of life emerging in other star systems. The specific way stars form and mature within these clusters could directly impact the creation of environments suitable for life, meaning each new discovery could have profound implications for our place in the cosmos. Looking ahead, it's thrilling to contemplate the ultimate destiny of these massive structures. Will they merge into even larger superclusters, gradually disperse, or eventually fall apart over eons? The evolution of galactic clusters is a captivating subject that encourages us to speculate on the long-term future of the entire universe and the new formations that time has yet to reveal. Galactic clusters also provide a fertile testing ground for string theory and other pioneering ideas in modern physics. The quest to understand how these theories connect to the universe's structure and the nature of reality is a powerful testament to human ingenuity and our relentless curiosity to explore the unknown. Ultimately, it's crucial to remember that every cluster we observe serves as a profound reminder of the sheer vastness and mystery of our universe. Each new piece of knowledge brings with it a fresh set of questions, and it is within this constant pursuit that you find the true elegance of science. Astronomy, much like the universe it studies, is perpetually expanding, with galactic clusters playing a leading role in this epic story. So the next time you gaze up at the night sky, know that you're not just seeing distant lights but are witnessing cosmic history firsthand. With every galactic cluster we analyze, we take another step toward unlocking the secrets of the universe. This journey, fueled by a curiosity that must never diminish, has only just begun, with the history of the cosmos written in the stars, and we who are here to narrate it.